Okay, so for the exam of last semester, the second question called the second output. The output is equal to 1 if the input variable is a multiple of 3. يعني هنا يعني خلينا نشوف البروبلم the general problem انه عندك هنا زي الكونفرتر فعندك input و you will convert this input to an output. فهنا بيعطيك شنو الانبوت وبيعطيك وين الاوتبوت يكون يساوي 1. هنا طبعا هنا عندنا تو فانكشنز. فهنا السوليوشن هي انه you just need to draw الانبوت تبعك A B C D. طبعا هنا البلوك دايجرام بيعطيك هنا عندك 4 inputs A B C D وهنا you have two outputs function 1 function 2. فهنا you just need to draw the table, the truth table, بعدين try to find the rows where you have 1 here. 0 1 0 0 0 0 1 0 1 0 0 1 1 1 and then 1 0 0 0 and 0 0 1 1 0 1 0 1 0 1 1 1 1 0 0 1 1 0 1 1 1 1 0 1 1 1. Here I have 4 plus 4, so I have 8. You can draw lines like this just to make sure you have 16 entries in the table. طيب هنا we have F1 and then here we have F2. The second function is 1 when the input is a multiple of 3. يعني if the number is equal to 1 3 ضرب 1 يعني 3 is equal to 3 فهنا this is 1 or 6 يعني 2 ضرب 3 is 6 so هنا this is 1 or 9 so this is 1 or 12 هذه 8 أو 4 this is 1 or 15 this is 1. All the others will be zeros. That's it. يعني you just need to يعني to transform the definition the specification to something like this. يعني ايش المش مفهوم يعني هنا؟
هذه دي calculated if it's more than 3. انا ما عرفت يعني
multiple of 3 ضوارب 4 يعني ضوارب 3 اقصد يعني multiple يعني اعطيني الارقام اللي هي multiple of 3 3 6 9 يعني 3 ضرب 1 3 ضرب
يعني المين تيرمز الثالث بعدين مين تيرم
نعم
يعني المين تيرم الثالث والسادس والتاسع وال12
نعم هذا قيمة
اوكي كذا
القيمة هذه
انا فهمت غلط.
اي القيمة هذه 3 this is multiple of 3 هذا multiple of 3 ايضا يعني it's very simple بس يعني just need to understand for the first output the output is equal to 1 if the input variables have more ones than zeros. If you have more ones than zeros the input is 1 هنا it's 0 هنا it's 0 هنا 0 هنا 0 0 0 it's only 1 يعني في when you have 3 ones that's it or 4 sorry هذه 1 اوكي
بالانسر يا دكتور اول واحده كانت 1 over 0
هذه
F2 ايه
كتبت يعني 3 ضرب 0
مكتوب 1 over 0 هذه استقع يعني 0
الاولى 0 هذه يعني انا كتبت في الانسر هنا 1
لا مكتوب 1 over 0 1/0
ما معنى 1 سلاش 0 يعني
ما ادري
هنا كتبت كده
اسوي لك ستريم للانسر.
كتبت كده انا.
ايه كانت كذا.
اوكي، هذه that's the answer that I used for correction. يعني هذه if the student هنا وضع 1 ولا 0 I accept it يعني.
اوكي.
يعني if he considered that 0 is a multiple of 3 لأنه 3 ضرب 0 is 0 I will accept the answer يعني.
اوكي.
Okay. Do you want to continue solving the exercise هذا؟
إذا سمحت دكتور. إيه.
طيب أنا يعني أحب I want to continue لأنه I have seen that في still a lot of problems في K-maps. You still have a lot of problems in simplifying the expression using K-maps. Zero 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 one 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 zero 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 one 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 zero. طيب the first يعني error that is done by students and هنا they don't have the same يعني order as the one that we have here. هنا if هنا you have written I0 I1 I2 I3 يعني I0 I1 are the bits with the highest weight. يعني when you say 0001 you have to find the correct يعني place. يعني هنا if you choose to put I0 I1 هنا so 0010 is this cell. لكن if you put I0 I1 هنا 0010 will become 00 هنا it will become هنا. Okay, so it's different. So يعني to make it simple just keep the same order. هنا إذا كان you have A, B, C, D write them in the same order هنا so that you don't make mistakes. Also you have to name the inputs. Make a little diagram like this, a little block diagram and name your inputs. هنا A, B, C, D. هنا A for example هنا is the bit with the highest weight. Okay, so هنا we'll make the truth table for F1 with one color and maybe F2 with another color. We'll see. So F1 هنا 0 0 0 0 so 0 0 0 0 then 0 0 0 1 0 1 and then we jump on line 0 0 0 1 and then 0 1 1 1. So here we have to take these groups. Are you okay with this?
Yes.
Is it clear يعني ولا لا؟ I have seen
إيه clear.
I have seen in the major two I think or in the quiz I forgot. I have seen students grouping groups of 3, which is forbidden. إما groups of 2, 4, 8, multiple of 2. Okay, the groups cannot be groups of a number that is not a multiple of 2. I mean a power of 2. Sorry.
What about 1, mister?
نعم.
1 only 1.
Of course. 1 is a power of 2 يعني 2 to the power of 0, 2 to the power of 1 and so on. Now 1 you can have only one bit يعني. Okay, so هنا also another error I have seen students making grouping like this. You cannot do this. يعني the cells have to be adjacent either horizontally or vertically. They cannot be grouped like this. يعني diagonal هذه ما هي موجودة. What else? What kind of errors? I have seen students make groupings like this with a 0 in the group. Zeros should not be included in the group. If you include 0 in the group, that means that you are treating it like if it was a 1. Yeah, and for you it's a 1. Okay, so zeros, they should not be included in the group. What else? I have seen also students making this error. So once they grouped, let's say they group these two together, then they will group every one of these, each one by itself. Yeah. So يعني هنا they think they covered everything. This is incorrect. This will give you an expression that is not optimized. The expression will be correct but not optimized. هنا you have to maximize your groups. هنا you cannot group الوان هذا by itself لحاله. You have to maximize. You have to group it with this because يعني you can. Okay, also for this one هنا you have to group it with this bit here. With this one also you have to group it with this bit. You have to maximize the groups. بعدين also there are some mistakes in extracting the expression. So هنا for example the expression for this group is, what is the expression هنا? You have an idea?
A, B, D plus.
A cannot be in the group. لأنه A is changing هنا.
Okay, I was saying something else. Sorry.
No, I'm talking about this group.
CD, BCD.
Exactly, BCD. What about this group,
ABC.
ABC. Then
CD and ACD.
CD. So before doing the last one, we should find a common factor. We will have 4 terms and we should find a common factor. What will be the common factor here?
C.
No, it will not be a common factor, but it will be a term. It will be a mean term. What is the expression of this mean term? The one in the middle.
A, C, D, or B.
A, B, C, D. This is 1, 1, 1, 1. Okay? So A, B, C, D, because it's covered by all the prime implicants that we selected here, A, B, C, D will be included in each one of these expressions. So here B, C, D, in reality, this is A, B, C, D, or A bar B, C, D. Okay? So it covers A, B, C, D here and A bar B, C, D. These two mean terms. A, B, C here, this prime implicant, in reality, it covers A, B, C, D or A, B, C, D bar. Okay? So this is A, B, C, D and this is A, B, C, D bar. Is it clear? Is it clear what you have here now?
Clear.
It's clear why we have the ABCD will be apparent, or will be included in all of these terms. It's because it's there. Yeah. So also this one ACD, in reality it's ABCD or AB bar CD. Same thing here. We will have ABCD or ABC bar D. So if you have ABCD and ABC bar D, this will be in reality ABD. ABD. So if you look at the group, you will have AB and the bit that does not change in a D. So we have ABD. So ABD, in reality it's ABCD or ABC bar D. Okay. I'm just trying to make sense, to make more sense يعني about the groups يعني. What the groups mean يعني. The groups they mean that they have in a common factor that you can get rid of. Not a common factor, but يعني هنا we can put something in common to get rid of one variable. And the one variable is the one that changes between the two mean terms. Okay, so this is the first function, f1. And then we have the second function, f2. Let's draw second table for f2. Zero, 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 one, zero, one, 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 zero, 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 one, zero, A, B, C, D. So this is for f2. So f2 is 0, 0, 0, 1, 0, 0, 0, 1, and then 0, 0, 1, 0, 0, 0, 1, 0, and then 0, 1, 0, 0. We have to jump, 0, 1, 0, 0, and then 1, 0, 0, 1, 1, 0, 0, 1. So here clearly we don't have any groups. So here we have to take the 5 mean terms, each one by itself. We cannot make any groups here. They are all essential prime implicants. You just need to take the midterms from here directly. So A bar, B bar, C, D, then A bar, B, C, D bar, and so on. Okay? Do you have any other difficulty? Here it says implement the circuit using a decoder. Do you know how to do this?
Yes, so implement the F and F2 by an OR gate, right?
Yes, you have the decoder. Here you have the decoder. You have the decoder has do we have the information about the decoder? Implement the circuit using a decoder. We don't have any information about the decoder. So here the decoder, maybe we have 4 inputs. So maybe here we'll have 4 inputs. If we have 4 inputs, we'll have 16 outputs. Let's clear this table. So here we have 4 inputs. So let's use A, B, C, D as inputs in the decoder. So for the decoder, this is I3, this is I2, this is I1, this is I0. And then here we'll have 14 outputs. 16 outputs. Let's call them D0 to D15. So this is a 4 to 16 decoder. So the function f1 is equal to, so if we write it here, f1 will be equal to BCD or ABC or ACD or ABD. Okay. So when we have هنا let's look at the first midterm هنا. That is 1, for example. 0, 1, 1, 1. So when we have 0, 1, 1, 1, the function is 1. Okay? So 0, 1, 1, 1, which corresponds here to 7, to D7. 1, 2, 3, 4, 5, 6, 7. Okay, so this is D7. So when we have 0, 1, 1, 1, D7 will be active. Okay, so if we here we have 0, 1, 1, 1. Here we activate, the decoder will activate D7. Okay, so here BCD, or so we take BCD, BCD. So it's here we have to take it directly from the decoder. This is the expression, but to implement it as a decoder, we have to take the expression directly from the midterms. It's easier than trying to deal with this. Here we have A, B, C bar D. So if we have A, B, C bar D, yani 1, 1, 0, 1, which is 1, 1, 0, 1, which is 8 plus 4, 12, 13. So we take D13. 8, 9, 10, 11. This is D13. This is F1. So we took this midterm A, B, C bar D. Now A, B, C, D, which is D15. And then A, B, C, D bar, which is D14. Now this is D14. So it's this one. And then we have A, B bar, C, D. So it's 15 minus 4 is D11. Okay, this is F1. It has 5 midterms. Here also it has 5 midterms. So we have A bar, B bar, C, D. This is 3. So we take D3. This is D3. Then you have A bar, B, C, D bar. So it's B is 4, C is 2. So this is 6. So this is D6. And this will be F2. Then you have A, B, C bar, D bar. This is 12, D12. Take D12. Then you have A, B, C, D. This is D15. Take the same here. And finally, A, B bar, C bar, D. This is 9, D9. 8, D9. It's this one. Is it clear? Is it clear for you how we built this?
Yes, it's clear.
Clear.
Yani with the decoder, you just need to OR the midterms. That's it. Yani it's not very useful to have the function. The function combines the midterms in a more optimized way. Like with the decoder, you need to consider the midterms y by 1 and all of them. Okay, so this was this exercise. You have other questions?
Can you solve, Mr. the exercises regarding 4.1 and 2 and the exam, the final, the mathematical ones?
These ones?
Yes. No, these are definitions. I mean the one that require حسابات يعني كذا. أي زي هذا.
Okay. So for a RAM memory of size 32K multiplied by 8, answer the following question: how many address lines bits are needed? So here we need how many address lines we need to. So this syntax here, this means that we have 32K addresses multiplied by 8. So 8 is the size of the data lines. So here how many data lines? Here we have 8 data lines. Okay. So here the answer is 8 for B. For A, how many address lines? So 32K.
It's supposed to be 2 to the power that equal 32.
2 to the power 52?
No. 2 to the power something equal 32, right?
دقيقة. So 2 to the power of 32 هي لا هي 32
32K.
32 هي
انا قصدي الناتج يكون 32.
نعم 2 ضرب 2 هي 2 ضرب 2 4 ضرب 2 8 ضرب 2 16 ضرب 2 32. So it's 2 to the power of 5 multiplied by 2 to the power of 10. هذا الكيلو. Okay.
ليه 10 مستر؟
Sir, is the final same for all the sections?
نعم.
Is the final same for all the sections?
والله ما سمعت.
Is the final same for all the sections?
I did not understand the question.
دكتور قاعد يقول هل الفاينل حيكون موحد؟
نعم, yes, it's unified. So K here 2 to the power of 10. So here we have 2 to the power of 15 addresses. يعني the size of يعني I think we call it M is the number of bits for the address registers or and bus or 15 address lines. 15 here, okay? Is it clear or no?
Clear.
Okay, what are the control lines? Hina they don't change. They are always the same. And then read, write. We have the memory function complete, MFC. And we may have an enabler. What would be the size of the MDR register? So the MDR register.
Same as the data lines.
So has, no, this is the data register now. It's the same as the data lines, so it will be 8. And the MAR will have
same as the address lines.
As the address lines, 15.
What did you say, Mr., about C? The control lines are needed.
Here we have the write, the read, the read bit, the write bit. These are inputs, يعني control lines. بعدين we have the MFC. It's an output. It's not control, it's an output, but يعني we can include it هنا. It's the bit that the memory uses to tell the processor that it has completed the operation, the memory function complete. And then we may have an enabler. We called it, I think, EC or something in the slide. It's an enabler. Okay, so you have other questions?
ايه تحتها يا دكتور؟
هذه this one?
Yes.
So in a computer with cache hit rate of 97%, where the cache access time is 100 nanoseconds and the memory access time is 1000 nanoseconds, find the miss ratio. So if the hit ratio is 97%, the miss ratio is 3%.
3%.
That's it. You don't need this data to compute it. Find the average access time. The average access time is, it has a formula. It's 0.97 multiplied by 100 nanoseconds plus 0.03, sorry. Here, don't make the mistake. 3% is 0.03. 0.03 multiplied by 1000. So here in this example, it doesn't tell you what is the policy or what is the architecture that is used if when there is a miss here, we have a miss here, 1000 nanoseconds. Do we have to load the data in the cache and then access the data from cache, or we can do this in parallel? We have seen in the lecture that you have two different policies, two different architectures. One architecture that do this in parallel, and one architecture that has to load the data in cache and then access it from cache. So if we had to do that, it would be here 1000 plus 100 nanoseconds.
So we add the catch time.
نعم يعني في two policies. If we access it directly on memory when we don't find it in cache, so you just add 1000. لكن if we have to access it in memory, load it into cache, and then access it from cache, so here you have to add the 2 times, 1000 plus 100 in this situation. Is it clear?
Yes.
So we will have two formulas. The first one is this, the second one without the 100. So it depends on the architecture. Here it doesn't tell you, so just use the second one. And here you just need to compute this. And of course, it will be in nanoseconds. The unit that we have used is nanoseconds, so it will be in nanoseconds. Here I think it gives 115 or something nanoseconds. If I remember, I think it's 115. I don't remember, but yeah. Then find the improvement in performance where time to access main memory is 1000 nanoseconds and time to access cache is 100 nanoseconds. So here the improvement in performance is 1000 divided by 115. So that's the improvement. Is it clear? improvement هو نعم improvement يعني هو how many times we accelerated the access, so we have to divide the time without cache divided by the time with cache, so you will get 8 or something, 9 maybe 9 point something or something يعني حاجة زي كده.
Sir, in the answer is 0 for this one.
Excuse me?
The answer is 0 for this question in the answer key.
0?
Yes.
How do you mean? What do you mean 0?
In the answer key.
No, maybe I did not solve it there, maybe.
Okay.
It's not 0.
Mr. You mean 1000 over 110? Why 115?
What is the result of this line? I did not compute. I did not compute it. I don't know. يعني هنا we computed يعني 0.97 multiplied by 100 equals plus 0.03 multiplied by 1000, 127. So this is 127. So if you divide 1000 by 127, You find 7.8. So here we found this means that the processing or the access is 7 times faster with cache. Okay. Yeah, is it clear or not?
So you divide the access main by the average time.
هو قال لك improvement. How do you compute improvement? You compute improvement by dividing the time to access data without cache by the time to access data with cache. So here you find this factor. So this means that the time to access data with cache is 7 times faster. Okay.
Okay, thank you. Okay.
You have other questions? Do you have any other questions or no?
Last question.
Solve, Mr. The bus question.
اللي بعدها
ايه اللي بعده حق الباسز.
this one.
Yes.
Okay,
Part
this
2.
هذا حفظ يعني list the main types of bus arbitration. So you have the central arbitration, then the distributed arbitration. Yes, and
السؤال اللي
then
تحته.
هنا what type of bus architecture is given هنا? This is the central arbitration with only one bus request line. With the single bus request line يعني that uses daisy chaining. This is daisy chaining, you know. List the order of input-output devices based on their priorities. هنا what are the priorities هنا? يعني the highest priority goes to which device?
The first one.
One.
هنا the priorities are fixed and يعني they have the same order of the elements. The first one is the first one. يعني it's the one that has the highest priority. If it requests the bus, it will take it right away. يعني it will take it when it's free يعني. So that's the answer. What are the advantages and disadvantages of bus arbitration, of that bus arbitration type, of this one? The advantages is that it's simple to design, to engineer. Yeah. It's not very
cheaper.
expensive. It's not very expensive because it doesn't have a lot of lines. Advantages, easy to implement. What else? Do you remember other advantages? So the disadvantages is that if we lose any component here, we break the chain, which means that the system is not very fault tolerant. If device 3 stops working, it will not pass the bus grant signal to the components that come after it. So it's not very fault tolerant. What else? We have a more important drawback here. Can you find the other drawback? You have an idea or not? Can you hear me?
Yes, Mr. But I don't have an idea. Unfortunately.
Okay, so هنا this is very common. يعني we will يعني you will encounter this drawback in many systems where you have priorities and where the priorities are granted in a static way. So هنا the priorities are granted in a static way يعني one always have the highest priority. يعني even if the component one asks for the bus uses it. And now let's say, for example, component 5 is asking for the bus, but it will not take it because component 1 has highest priority. So one asks for the bus, and when it finishes using the bus, the arbiter will look if there is another bus request. So it will find that 5 is still requesting the bus. It will maybe at this time 3 will issue also a bus request. So the arbiter will issue a grant. It will go to 3. When it goes to 3, 3 will take the bus. So 5 will still be waiting. Yeah. So these 4 components, or let's say even these 3 components, they will be using the bus all the time maybe, and maybe 5 will wait yani indefinitely, a very long time until it gets the bus. Okay, so this is called starvation. This is a very common problem, starvation, when you have static priorities. Okay, so that's the biggest disadvantage. Then it says explain the following and write the formula or applicable. This is not very important. Pipeline, you know what is pipeline. Let's go to 8. Suppose you are using risk architecture where every step takes 1 clock cycle to solve. You are using Pentium 4 style that is 20-stage pipeline. Question 1. I have 30 instructions in a program. I have 30 instructions in a program. How many cycles it will be taken to make the pipeline full?
20.
Yes, we need 20 cycles to make the pipeline full. So this is called in the slides the pipeline setup time. This is the setup time, the time it takes to fill the pipeline. What is the total execution time?
It's the same as the number of stages.
نعم.
It's the same as the number of stages.
نعم, you need يعني for each clock the first instruction will advance by 1 block. So after 20 blocks, after 20 clocks, the first instruction will be at the last block. So at this time, we have all the pipeline will be full. Yeah. All the stages will be full, occupied. So we need 20 clocks. What is the total execution time? I think here they mean the total execution time of the 30 instructions. So what is the total execution time here? So we said that we need 20 clock periods, 20 clock periods to set up, to fill the pipeline. And then after these 20 clock periods, for each clock period, 1 instruction will finish. So after this, if you add 30 clocks, all the instructions will get out of the pipeline. Are you okay with this?
يعني دكتور هي ال 30 clock periods على اساس الانستركشن صح؟
نعم, if we have 30 instructions. Of course
يعني
هنا
عندنا
this is the ideal situation where we don't have any constraints. Okay?
تمام.
Is it clear this computation, how we computed this?
Yes, clear.
clear? So we need 20 clocks to fill the pipeline, but after 20 clock periods, we did not complete any instruction. But starting from the 21st clock period, we will start issuing one instruction per clock, per clock period. Yeah. So after 30 clock periods, we will finish executing all the program. So 50 here. I think this question here is incorrect. What is the throughput? To compute the throughput, you need the frequency, so that there is an error here.
The throughput is 1 over the frequency, right?
Hey, you need the frequency to compute the throughput. You cannot compute it just like that. Yeah. So there is an error in this question.
So if the frequency is 10, the throughput is 10?
If the frequency is
10 megahertz.
10 megahertz. Okay, if the frequency is 10 megahertz, let me think. So 10 megahertz. Yani this is 10 to the power of 7 hertz. Mega is 10 to the power of 6. So it's 10 to the power of 7 megahertz. Yani clock period is 1 على 10 to the power of 7, يعني 10 to the power of minus 7 seconds. So this is the throughput. يعني you can execute one instruction each 10 to the power of minus 7 seconds. يعني 0.1 microsecond. يعني
Mr. I said 10 minus...
nanosecond.
You said 10 to the power minus 7, not minus 6.
نعم minus 7 يعني 10 to the power of minus 6 ضرب 10 to the power of minus 1. So minus 6 is nanosecond, is microsecond.
Oh, okay, sorry.
So this is 0.1 microsecond. But يعني it's also 100 multiplied by 10 to the power of minus 9, which is nanosecond. So it's 100 nanosecond to issue one instruction. So here, because we have a pipelined processor, the throughput is exactly يعني 1 clock period. So we don't multiply by the number of stages because we have a pipeline processor. So it's 100 nanoseconds or 0.1 microsecond. Is it clear? Do you have any other questions?
دكتور عندي سؤال عن الاختبار بشكل عام.
نعم.
عندي سؤال عن الاختبار بشكل عام. هو بيكون كم ساعة؟
3 ساعات هو أعتقد.
اوكي.
أعتقد هو 3 ساعات. 2 hours. سوري سامحني، هو الساعة الرابعة.
اي الساعة 4.
اي الساعة 4 3 ساعات للاختبار. هو في الحقيقة الاختبار يعني احنا وضعناه انه ينعمل في ساعتين يعني. بس الجامعة حددت انه المدة الزمنية في اللي بعد العصر راح تكون الاختبارات كلها 3 ساعات. حيكون عندكم الوقت كفاية.
تمام، شكرا دكتور.
عندكم أسئلة أخرى؟
Sir, about the quiz 5.
والله ما سمعت.
The quiz 5.
The quiz؟
The fifth quiz, the best of 4.
والله I'm not hearing you well. Sorry.
I'll write in the chat. Okay.
The chat. What is the chat? The quiz 5? Digital logism. What about it? Quiz 5. You want the grade, you mean?
Yes, the grade.
The grade, wallahi, I'll try to give it to you tomorrow. Inshallah.
Okay, inshallah.
Inshallah. I will try. Any other question?
The grade of the logism, right, Mr. You'll give it tomorrow.
هو سهل على logism.
It will still be the best out of 3, right?
Hey, inshallah.
Okay, thank you.
You're welcome. Any other question? If you don't have any other question, I think we can stop here. Okay?
Yes, sir.
الله
Thank
يعطيك
you.
العافية دكتور. شكرا.
Thank you, Mr.
شكرا.
Thank you.
Thank you.
تنزلها على لمس التصوير صح؟
ان شاء الله. حنزلها الحين ان شاء الله.
يعطيك العافية.
السلام عليكم.